I just want to ask Thomas if I would invite you together. So maybe we
Okay,
can
I can.
together.
Yeah, I can also come. Yeah, sure.
Yes, please.
Hello.
Hi, Daniel.
Right.
Hi, Sandrine. Please come in.
I can
Tea, coffee.
no, I just finished my tea.
Okay, I see.
Okay.
Yes, please. Now, let's discuss.
Hmm?
Certainty.
The printing, yes, the printing. So I'm not sure. Actually, I have checked some code that she gave me,
Okay.
and then I see nowhere to control the thickness of the painting. So if I'm not sure if it's available from your
So, first, tell me what would you like to do?
yeah actually
Because
yeah.
most likely thickness of the serpentine is
Yeah,
formed
yeah, yeah, yeah,
spontaneously.
yeah. As you know, I and Sandri will do the redox dynamics from the subduction
Yes,
initiation
yeah, this
to
is
make
fine.
sure
No, but concerning serpentine, what is your concern? What would you like to prescribe? And then
yeah,
I will tell you what I can do.
yeah, yeah, yeah. Then this is the initial model, and then maybe it's a 0 MA, and this is 1 MA. So it's like this, when 1 MA or 3 MA. It's like this.
Correct? Yes.
Yeah, yeah. So I would like to know the thickness at a different time.
I mean, you can have this from the pixels of the models,
Yeah.
but the question is if this is it reasonable in the model or not. I think this is more the question. We were discussing this.
Yeah. So the issue is it's all based on the water contrast. However, of course, original content of water is not regulated. Is not feeding back to the color. So even if you have 0.01% water, it will in serpentine stability field, it will still be called serpentinite.
Yeah.
So potentially, what one could do is one can process the serpentinite markers in certain area and then compute how much water do they contain,
Yeah.
and then recompute degree of serpentinization, and based on that you can make some inferences about water reaction, because by using colors themselves, it does not tell you how much water, how much eventual serpentinization reaction has happened in rocks.
So you need to compare the pixels of the serpentinite with the pixel of the water content and see if this is.
Yeah, you probably have to do, what you have to do is to rather, modify this post-processing routine
Yes,
for
yes.
output of water, and make, instead of output of water, make output of degree of serpentinization, which will be something in between 0 and 1 for marker type 13, and for all other markers, irrespective of the water content, you just make 0.
And what? Which?
Yeah, so you have this mark T is the rock type, right?
Yes. Yeah.
So this is rock type.
Yeah.
Type. Then mark W
Is the water.
is the water content.
But that's the free water or the
No, it's just
water in the rock?
it's water in the rock.
Found
For
it.
serpentinite will be definitely mineralogical content of water, and since water there is contained by serpentine, right? So then it tells you about degree of serpentinization. So essentially, 30% water content will be pure serpentine, right? But then if it's much less than that, then you can compute proportion of serpentinization. Or Vinion can just use water content as
Yes.
proxy for the degree of serpentinization reaction.
Yes. I can use some maybe some observations waters. Then I will tell you
Yeah.
how much waters it's reasonable. Maybe
Yeah.
it can be used.
Okay.
No, this is, this is computed based on the water transport model. So then, essentially, if you would like to compute how much of your redox reaction has happened due to serpentinization, this is exactly the proxy for the degree of this reaction.
Yeah.
So, because in most cases you will find only partial serpentinization. If you do not prescribe this, the initially kind of thick serpentinite layer underneath the crust, what will happen is rocks, they will release fluids will go up and down according to pressure gradients, and then they will, if they reach mantle and conditions are appropriate for serpentinization, water will be consumed, which imply that serpentinization reaction will happen. So, and then the degree of serpentinization reaction is in fact reflected by the amount of water which has been consumed, because originally this mantle is just dry. And we do not have any porous water in serpentinized mantle, so all water there is just water in the serpentine. So then visualization, if you would like to see this on the pictures, you can modify this water visualization routine by only showing water of type 13
Yes.
and not showing water of any other type.
Yes.
And then pictures in pixels will and in water content will give you exactly the degree of serpentinization reaction.
Yes. Yes.
So this is how I would go for it.
Okay.
Yeah. So it's just to pay attention because only looking at the water at the rock type, you have no idea how much water is sitting in this serpentine, and they will definitely have very different amount of water because there might be very little water for serpentinites which are sitting underneath the oceanic crust, because water markers are difficult to reach there, and there might be much more water. Anyway, there is an upper limit for water consumption which is given in the database, which is 2.58%. So it's only partial serpentinization which is assumed. It's not never complete serpentinization. Potentially we can change this if necessary in the future, but so far it's only partial serpentinization. So 2.5.
Yes.
So the maximum. Don't be surprised that.
Actually 2% it's reasonable, I think, but 2.5 is also good. Yeah.
Yeah, exactly. And then you will see that probably in majority of cases underneath the oceanic crust where water is sucked down by this, by bending faults and so on, there will be much less than that. Probably there will just be trace amount of water. While in the mantle wedge atop the subduction zone, you will see much more, like in the serpentinite melanges, which Sandrine also investigated. You will see much more water, and probably in many cases it will reach this eventually 2.5%. Yeah. So, and I think this would be the way to go for water and degree of serpentinization, and more or less how much hydrogen has been released due to that and so on. Okay.
So the thickness of the serpentinization is can be dealt with by the I2 views, right? Yes.
Yeah, exactly. Yes.
Actually, in your models, you just need.
I need to post-process the models. Yeah.
Okay.
Yeah. You have to just go to the models and then see. And in principle, the principle there is such that if fluids are going from the slab, and then they are facing mantle, which is undersaturated by water, then water is spent to further saturate this mantle. And as soon as mantle is fully saturated, then these water fluids are going up further. And then they are starting to saturate. But since water fluids, for example, can be released due to, for example, deserpentinization reaction here, then you might sometimes see these very big spikes penetrating through the entire plate for the reason that lots of water is released here. Here is rigid lithosphere, therefore pressure gradients are mostly vertical, and then just all fluid goes up and serpentinize or hydrate the mantle. And here it's more kind of diverse because there are lots of different reactions at different depths from basalt, from sediments, for example, and then you typically have some kind of serpentinized channel formed here. And then what happens in the channel, material is displaced downward, which is competing because you have some kind of subduction erosion. Yeah, so then the thickness of the subduction channel is some kind of a dynamic quantity which is formed gradually within there. And it's competition between subduction erosion and new production of serpentine.
How is it actually? How is how is the depletion in the model modeled? Is it is also based on markers, or is it based on
No, it's based on markers.
right?
Yes, depletion is just fully based on markers. You extract melt, and then your depletion variable is updated.
Yeah, and the depletion variable is only based on the residual melt, on the melt that the amount of melt that has been extracted.
Exactly. Yes. So the principle is the following. So you have kind of batch melting model, which allows you to compute M0. So essentially,
Yeah.
as a function of pressure and temperature. This is for completely fertile mantle
Yeah.
at the given pressure and temperature and water content, PTH2. At the given pressure, temperature and water content, you can compute M0,
Yes.
degree of melting.
Yes.
However, rock, it has memory about how much melt has been extracted.
Yes.
So then eventual amount of melt is computed as M0 minus M extracted.
Exactly, the thing we
Yes,
put in.
exactly, yes. And then this is what is,
And this is the degree then of
Yeah.
depletion.
it's
basically.
mark X variable.
Yes.
So this is mark X.
Yeah.
And if you decide that this difference is big enough, you do yet another kind of step of extraction, and then you update this variable, and then it's become even bigger. So in order to produce more melt, you have to either increase water content or increase temperature or decrease pressure.
Yes, yes.
So-
Then it makes sense. Now
Yes.
I understand. Yeah, yeah.
So unfortunately, this is not really the fully realistic model, because fully realistic model would be to just trace fully the composition of rock, and then based on this composition, update composition by melt extraction. We don't do it in a way.
But then the whole model needs to have like a memory of what.
Exactly,
what
yes,
we have.
yeah. Then it has to have a memory of rock composition, and then phase diagram for every rock composition, which is relatively difficult to manage.
Very difficult.
So then we use this relatively simplified model of melt
Yeah,
extraction. And it's all it's the same for all rocks, so it's assumed that there is some standard melting diagram irrespective of whether there is some extraction before. Or
Yes, exactly. So when there is extraction and something will be extracted, the depletion will be based on the previous extraction.
Exactly, yes. Yeah.
Mhm.
Yeah.
Now I have the other questions that we talked before.
Mhm.
How could we get the different PT paths from the
Mhm.
different layers of the subducted slab?
Yeah, each layer of subducted slab is composed of so-called markers.
Mhm.
So then you can follow any marker during the entire experiments.
Okay.
And simply, there are post-processing routines which allow you to trace back.
Mhm.
You choose just any of these markers or
Okay,
any
okay,
area, and then
okay,
say I would like to trace back what are PT passes.
Yeah,
Oh,
yeah.
really?
Yes, yeah, no, there is this somewhere there is a code which does it, and I can send it to you.
That would be great.
Yes, I
Yeah,
can
yeah,
I can
yeah.
do it. Yes.
Yes.
Because I was running some other 2D models because we were hoping for getting like the whole IBM lithology.
Yeah, you will most likely have to adjust the format of the file of PRM. So in terms of variables, how many variables? Because I was doing this for some of these previous formats. So somewhere it should be here. Some pretty 2017, and then I2 slot PT passes. Yeah, so here.
you say, but
Yeah, the issue is,
Wait,
I cannot guarantee that
Sorry.
no problem, that your list of variables, it will be the same as the list of variables. So this list of variables may be different from the list of variables of your code, and similarly also for the markers, because here you have to process markers, and then here it's assumed that you read for every marker you need 11 variables, but it might be that you read instead 12 or 10. You have to check. You have to check format of your file, whether it will fit to this or not. I cannot guarantee.
so the format of my file is,
Of your PRN file.
and how do I check it? Because
Yeah.
I mean, it doesn't really matter what I am extracting, right? I can extract.
No, the issue is you can only correctly read variables from files if you prescribe format of the file. So how many of nodal variables you have. So here you have how many of different, and you have to look into load fast or load slab to see how many variables you are reading.
Okay.
So, and then if something does not work, then you have to, to correct here number of variables. For nodal points, so here it's assumed you are reading 24 variables in total. So
Okay.
3, 13, another 3,
Which.
3, 13, yeah. Integer float, yeah, probably +4. Yeah, then also integer 64 are counted as floating 32 probably. They have the same.
Okay.
So you can count. So here 3 plus 13, 16, 19 plus 3, 22. And then something is wrong. Plus 4, so it's a one integer. One integer is what? Integer 32, I assume.
Okay.
1, 2, 3, so 3, 4, 13, 17, 20. What I not understand is, rock number, no, this is wrong. Here. Yeah, this now correct. This is where skip all nodes. Yeah, so here is now fine. So 1, 2, 3, but 16 plus another 3, 19. Yeah, so for nodal variables you have 19 variables, 4 byte each, and then integer variables you have 8 variables, or 4 variables, 8 byte each, or something like integer 64, 3. Integer 64, 4, yeah, 4 variables, 8 byte each. So this is the description of structure. And then for markers, important point is for markers, it's assumed that there are 11 variables, not necessarily have the same amount of marker variables. You probably have more, or you might have less, and you have to correct it in 2 places. So you have to adjust. But the code itself will not change structure. And here the approach is you just simply choose an area, x minimum, x maximum, y minimum, y maximum. You choose the file, 60, step, -5, for example, or -10, PRN. This is the index of PRN file, and then you go back.
I'm going back. Yeah, sure. Yeah,
Exactly,
yeah,
yes.
yeah. Okay. But a question: if that one is, I mean, who we talk about? Oh, yeah.
And if you will not manage, I will help you. But then send me load file.
Yes. I will look at it. So if the markers is outside of the area of interest, then it will.
They will be ignored.
Okay.
So what
But
it will
I
do?
mean, if even though I am tracing it back.
Exactly.
Okay.
Yes.
Okay.
No, wrong.
Okay.
Area of interest is only defined for the initial file.
Oh, okay.
You
then
don't
it's good.
care. You do not care. Where these markers, because they can be anywhere.
Yeah.
You don't care where these markers are coming
Yeah.
from. So it's just in the final. In fact, you can use any progression. You can say I start from this rectangle and then I go forward. Code does not know in which direction you go. And
Yeah,
it's
either
just an
plus or
important
minus.
point that the area is indicated for the first file which the code will process. And then in all other files, it will just use indexes of markers which it will collect from the first file, and then it will just go and trace these marker indexes in other files. So there it will not be even going through all markers. When it goes through the first file, it will go through all markers and select markers which are within the area. but then it will save the indexes of these markers. There are, for example, 1,000 markers. And then in the next file, it will just only look at these 1,000 markers. It's why it's important to just prescribe really the number of positions in the marker storage and in nodal storage, because otherwise it will not find anything correctly.
Okay. Yeah.
But you will see it. If you
But
run this code and you will not see normal pictures, this most likely imply that you miscounted number.
But when I have a slab and I want to trace the upper layer of the slab,
Unfortunately, a rectangle is given in such a manner. So essentially, like x coordinates, y coordinate. If you would like instead to trace some inclined layer, you have to write your own routine how you will find these markers in the first file. And these are different. There are different subroutines. One is dealing with the first file, and there you can make your geometrical flexibility however you want. But you will have to program it yourself. So how you kind of extract this area, it's up to you.
So it will come output x, y, and temperature, right?
It will output x, y, time, temperature, whatever.
Okay.
Let me check. And whatever you would like to trace.
Actually,
potential.
I need to shape the. I need to draw the subducted slab shape. So I only need to x, y, and temperature. It's enough.
Up to you.
Yeah.
Once again, you have any marker variable.
Ah, okay.
And moreover, here there is also interpolation of pressure.
Yeah. I know.
So
Actually.
then you
Yeah,
can
yeah,
also
Yeah.
extract water content, whatever you want,
Yeah.
because it's based fully on markers. So it should work. Yeah, so you have this code. But what is the field? If you want to help this, let me know. I will help.
Now I think we have the bending night thickness, and then we have the different pit parts. Then it's enough for me for the thermodynamic modeling.
Yes.
For 2D thermodynamic modeling. But I see actually in the EGU that there are some people have coupled your code with the Perplex together to output all the results in your I2 Wheels code. It's he's a PhD student of Fauci, right?
I don't know.
Your student, Italian, who
Manuele Facenda.
Facenda, yes.
Yeah, it might be, yes.
Yeah.
Cannot guarantee, yes.
But I will ask Connolly if there are some possibility or some problem on.
Yeah, no, of course I have versions of the code which is fully coupled to database, but we typically do not use it for the reason that, for example, inside the slab
it's
we
very
typically
slow?
have. No, not at all. It's fast, but typically it gives too high density inside the slab because
Yes.
it doesn't account for kinetic delay, so eclogitization happens immediately. So then we change to kind of more simplified treatment. But if necessary, this can be done.
Okay.
And in the code version, if you have this database, to use density from the database, you just write density mod -2 instead of density mod -3, and then it will take density from the database.
Okay.
For which rocks these densities are available.
Yes. Okay. So I think this project it's fine for it's enough. The
Okay.
Parameters is enough. But for the other project that on the plate tectonics with long-term oxidation of the metal, there's some problem of the actually the the weathering processes of the silicon continental crust, nobody knows that parameter.
Yeah, potentially, of course, one can implement some kind of. We always trace the surface in the code.
Yes.
So then, relative to the surface, we can implement also some erosion or sedimentation. This is implemented, but we can also implement some chemical weathering on some markers by introducing degree of weathering and so on for markers which are found at the surface or at certain distance from the surface. This can potentially be done, of course,
Yes,
but
okay.
it needs to be just described what exactly you would like to implement. So that then weathering can be done potentially.
Can you copy me two different subduction styles code to me when occur at New Akin or and at New Proterozoic, because I need to model these two different subduction styles.
I will ask my colleague
yeah,
Alexei
and,
Perchuk to send me these two reference models, and then I will forward it
and
to
then
you.
I will learn some
Okay,
something on that.
Fine, we'll do it.
Okay.
Yeah, if you do not hear from me, sometime,
Yeah.
then just remind me, and I will ask Alexei to send me.
Okay. Thank you so much. And okay, there is the last question I need to ask. Do you think about the snowball occurrences of the under the disappearances? It's my hypothesis of the new Proterozoic plate tectonic initiation again will occur the snowball Earth and the disappearance of the snowball Earth. Because as we can see, the observations show that at this one GA, this one 07 GA, the continental margins have increased very fast at 0.7 giga years. That means at this time I think the global subduction event has occurred, and during this time the snowball Earth occur at the same time, but the snowball Earth only continues for 10 to 15 million years. It's a subduction life scales. Yes, life scales. So at the first when the subduction before the when the boring being years are all the mid age, there are so many sediments and with
Correct.
so many like these minerals with these species, and they are in how to say the atmosphere and the water and the sea floor and the sediment. They are the recycling are
Yes,
in the
yes, yeah, I see.
in the balance.
Yes.
And when the global subduction occur very quickly or not very quickly, the global subduction event occur at 0.7 giga years. So that means this sediments will
They get
will go
subducted,
into
yes.
the will be subducted. So this balance will be break down, and then that means
You mean by addition of CO2 due to volcanic arc degassing?
yes, the CO2. No, I mean at first they are in balance, and when the global subduction occur at the first stage, the sediments will be subducted. That means the contents of sediments will decrease, and that means the more CO2 will be locked into the lock as such species in the sediments, because at first they are in the balance, and if these contents becomes decrease, and they need more CO2 to go to the sediments, and this this will lead to the atmosphere CO2 decrease.
And then cooling.
Again, then cooling, and then after subduction becomes mature or becomes all the subduction system becomes mature. This maybe 10 to 50 million years. They will be degassing.
Okay, I see.
Then warming and
Okay.
disappear, and the snowball Earth disappear, because this is a time scale of the subduction, from subduction initiation to the
Yes,
mature
yeah, it's
subduction.
an interesting idea, but we have to think about it, how to test it, and how to prove it.
Actually, yes, because we can set up the sediments. It's based on the thermodynamic modeling. Actually, I think. We only I look at paper that they can calculate the balance between the CO2 with seawater and the sediments, and if we can remove these layers, we can know how many CO2 will be decreased in the atmosphere. Then we can calculate the temperature, and then we can know the degassing rate by the thermodynamic modeling of the because based on the thermodynamic modeling we can use we can calculate how many CO2 will be formed at subarc depths, and
Yeah, but we cannot assume, right, that all subduction zones they are started at the same time, because you know subduction zone they should propagate globally, and this propagation process should take some time. And then while some are already relatively mature subduction zones, some others will be still very young, and then perhaps it's a balance in between subduction propagation and subduction maturation, which is leading to.
I mean here. Maybe at, for example, at 1 gigayears, there are some subduction have occur, but they are very. I mean, how could I say? It's a very. It's a few subduction at 1 gigayears, but at 0.7 gigayears, although there are some major subduction at here, but this may be a very big or very large event at 7.
Yeah, so what we can envisage is the following. You know, so the number of subduction zone here, and this is time. The number of subduction zone or length of subduction boundary or length of subduction boundary. This will be growing like this, right?
Yes.
And then and then essentially 10 million years later, this can be from 0 to 1. So it's 0 length to 1 is kind of fully established plate tectonic degree. And then actually this subduction zone that started early, 10 or 50 million years later, we will have essentially the number of mature subduction zones. Mature. Then we will have another line. This is maturation. All right. So then, with maturation, we have essentially CO2 release, which is offset relative to the development of new subduction zones. So essentially, what initially will be happening is lots of sediment subduction, and because of this offset, we will have climate cooling. All right. But then somewhere here. When these effects will start to become comparable, then perhaps there is climate warming and then return to the, or probably it will just warm somewhere here in between, or closer to when all subduction zone will become mature. So this will be some non-linear dynamic, because there is one dynamics corresponding to the lengthening of subduction zones globally, and then another dynamic corresponding to the length of mature subduction zones. And then if we assume that all subduction zones are living longer than these 10-50 million years, which is not necessarily the case, but Let's assume so. Then what initially will happen is because of more and more subduction zone growing, but none of them are yet mature. So then you will have definitely cooling until some mature subduction zone will start appearing. Then these dynamics will be slowing down probably, but then it will be inverted, and then it will come to the original level. So and this will all happen on the time scales which are corresponding to the time when all subduction zones are already so mature that actually there is no effect of this initial cooling, because as much as you create new oceanic crust, that much you are just releasing CO2 from the old oceanic crust. Or probably it will be more complex dynamic, because initially you will be consuming sediments which are very rich in CO2, and then later you will start consuming sediments which are more poor in CO2, because there was not enough time for alteration during the rapidly moving plate. So dynamic will not be very simple here, and one has to consider.
So you mean the time scales is very short actually. Maybe it doesn't work for this hypothesis, right?
Yeah, exactly. Yes, 10-50 million year implies that you have to propagate subduction zone globally on time scale of 10-50 million years. However, it's not impossible, because you will still have so you will have, for example, another 50 million years before that, because of subduction zones, they start to propagate, but none of them are yet mature. So you can have some period of time. So one can play with such models. Then you have certain rate of subduction propagation around the globe, and certain rate of maturation. And then you can probably, based on that and based on your assumptions of how many new ocean floor has been created, you can probably compute.
I mean, if the
because your model is in a way applicable if you assume that this line is just instantaneous. So you have vertical line, all subduction zones start in no time, or in 1 million year, and then essentially 10 or 50 million year later they all become mature.
Yeah.
And apart, not necessarily this is the case, right? So probably there can be kind of much slower scenario where all subduction zones are starting within, say, 200 million years.
I think there are maybe some impact from this line. If this line just like this, or if like such shape like this, no. Maybe this. What I mean is the global subduction event.
Yeah, potentially. Yes. Yeah, it's not impossible.
If like this, maybe it's possible to.
But then one has to prove that such type of subduction development dynamics is realistic. And for that, what is needed are global mental convection models with subduction unset, something that Shin Drew is working on, and also Timothy Gray may probably work on it. So then would be good to to check where they are with their calculation of the onset of subduction.
Maybe we can only to prove that in the observations, right?
Yeah, as the observation, best would be to show different models and then compare which ones are good enough, are dealing well with observation.
For example, you can say.
You know Shinju, who is postdoc in our group, right?
Yes.
Yeah, discuss with him, because he was showing me different scenarios of subduction initiation. Perhaps he can, trace the length of subduction zones and the maturity of subduction zones in his models. And this can be potentially recomputed in terms of what you are suggesting.
Okay.
So and then I think you will have, and then you can compare this with the natural observation.
Yes, because you can see at this time, actually it's like this line. This line, not this line.
Yeah, exactly.
Yes.
But then you should be able to find similar type of subduction propagation dynamics in the results of experiments that we did in He was showing me during EGU very interesting models
Okay, okay.
for global subduction propagation. He was dealing with mostly with planets without continents, but it's still, interesting to see the dynamics, whether it's linear as I was drawing, or it's non-linear like you are suggesting. Probably you're right. So, but best is just to make these conclusions on the basis of
Okay,
some models.
okay, I will do that.
Discuss with him.
Yes, actually, for these models, I also need the subduction styles during the neuroprotozoic. So,
Exactly, yes.
So I need your model
Yes.
code.
Exactly. Yes. This we will do definitely, and also from models that Shin is running, probably he also can tell you what kind of subduction styles he is
Okay,
obtaining.
okay.
Just discuss with him, explain him,
Okay.
what you would like to calculate. Probably he
Yeah,
will be
yeah,
happy to collaborate. I'm
Yes,
almost sure.
yes. Okay, then I think everything is okay, no problem for us. And we will first do the subduction initiation project. Then
Exactly. Yes.
this we'll do later, not
Yeah,
later,
no,
not later, but
just discuss with Shin, and perhaps he can extract from his models dynamics of the onset of subduction zones, and you can make and maturation. He can also extract different ages of subduction zone at different times, and then you can make conclusions. So you will have these two curves, curve for age of subduction zone. Or average age of subduction zone, and curve for the length of subduction boundaries. at
You mean
different
I
times.
must use the post code, right?
He's using pull code.
Yes.
Yes.
You mean Zhou Xin, right? Not Zhou Xin.
No, Shin. Yes.
Xin.
Shin Zhu.
Together,
With Jia Chen, right?
Yes.
yeah.
Xiaoxi. Okay, now I know. Okay,
True.
we know each other. Yeah.
Exactly. Yes. Yeah. Just discuss with him.
Yeah.
Explain what you would like to
Okay,
try to
okay.
evaluate, and then because
Now-
he will still be working on this onset of plate
Okay.
tectonics, essentially with
Yeah,
relationship to Neoproterozoic.
Yeah.
And perhaps you can just use results of his calculation to compare which of his subduction initiation styles will match with this, glaciation
Okay.
model.
Okay.
Yeah.
Okay.
And
Now
I think,
know that.
yes.
Okay. Thank you so much. And
Welcome.
I think we get everything we want. And yeah.
Yes. If you will have difficulties in changing number of variables, let me know.
Okay. I will learn that. Yeah.
Yes. And study the code, you will see.
Okay.
See you guys.
Thank you. Now?
No, I mean, it's tired for you, I think. I mean, you have already know how to control the bending water in the
Yeah.
affected slab. So
Yes.
maybe you can try first, then.
I can have a look. Yes, I can have a look, and I haven't used the one he sent us.
Okay. Then, okay. Then yes. If you get the pit parts and the thickness of something like that, you can let me know.
Yes.
I can
Yes,
do
I
that.
think I have an idea how to do the thickness. Like,
Yeah.
We-
If you have something to talk with me, I can go to.
I will come to you.
Okay.
I need to grade now some essays as soon as possible.
Doesn't matter.
So
Just.
this will be today. I will see if I can start this week.
Doesn't matter.
Yeah.
Based on your time.
Okay.
Okay.
Perfect.
See you.我操，这不是离我。